Good morning. How are you? I always say that I'm so pleased to be here. And thank you so much for joining us today for this wonderful, wonderful event. I only got 25 minutes, so I need to go fast. Please raise your right hand if you know how to ride a bicycle. Right, most of you, right. And raise your left hand if you know how to ride a motorbike. Okay, few quiet, others good. Now, please raise your both hands if you own or owned a Yamaha RX 100. 1, 2. Right, okay. Now getting closer. Raise your hand if you own a silver RX 100. Yes, I win. So, this used to be my bike when I roamed around the beautiful and peaceful roads of Bangalore back in those days, 91 till 96. Okay? So, it's not, Bangalore is not new to me. This is where I started my career from. Right, so if I now bring a bicycle and the motorbike, or what we call the two-wheeler, together, many of you are comfortable riding a cycle because you felt probably it's simple, it's easy. Once you know the balance act, then it's just pedaling, brakes, that's it, right? And probably the reason why many don't get onto a motorbike because they probably felt this is complex, or it's something hard to get through because there are two brakes, one on the foot, other here, and you need to think of clutch, accelerator, gear, and you need to pour the right fluid in, etc., etc. But the fact is, most of you are successful. You learned this trick. You understood how to deal with a complex, motorbike, and you're successfully navigating through the Bangalore traffic. To give you another example, you're sitting there, I'm standing here as owners of the most complex system in the world. I completely agree with Bill Gates on this. So when I say to people, they often say that, our body is probably not complicated, the brain is. I'm like, dude, isn't the brain part of your body? So this is the system we have. But unfortunately, we didn't have a choice. We are given this complex system. We are born with a complexity. As a child, we sit there and watch all the adults running and doing all sorts of things. We try to emulate. Then we realize that, to stand up, probably I need to sit steady first before I can stand. Stand first before I walk. Walk before I run. So we learned that. And elders and doctors say that, you know what? Inside your body is so complicated. You must take care of it. You need to eat the right thing, drink the right fluid, etc. So we understand that. And then we start to manage our body because we know how complex it is and we know how to manage it. Basically, what we do is we embrace this complex, human structure. So this is pretty much my talk today. So I will make you aware of the complexity in software engineering, in serverless, in cloud, or whatever we do. And I will try to make you understand about it. And then we'll see a few things how to manage the complexity. My name is Sheen Brisals, and I've been in the industry for many years. I am author of a couple of books. So the serverless book is available at the O'Reilly Straub's publication. I think they are selling for a discount. So, please go there and get a copy. And the speaker book is about speaking here. So if you want to stand here and talk, that book, explains all the things about, speaking at the conferences. Right, so how do we know about complexity? Thing is, complexity is everywhere. Because often we don't recognize it because it's always part of our life, right? So in engineering, Back in those days when we had mainframes, up until now when we have your smartphones and things, it's all complex things. Just imagine how much complexity or complicated stuff packed inside this small rectangle thing that you hold. That is the same when you host something, whether you host in your backyard, on-prem, or AWS or cloud. There is complexity, right? Same with highly debated, argued, and fought over microservices or monoliths. There is complexity. So to understand this complexity is necessary. Someone who understood this complexity early enough was the American scientist Larry Tesler. So according to him, every system we build has some element of complexity. You can't do anything about it. All you can do is push that complexity to here, or there. But the complexity is always there. I'll tell you a way to remember Larry Tesler. What is the number one skill required for a software engineer? What is the number one skill required for a software engineer? Come on. Sorry? Did anyone say copy paste? So, Larry was the one who introduced copy paste or cut paste back in those old days. So that's the way you can remember. Now, the other thing is, though we complain about complexity, we accept it because it's not always bad, especially when it comes to our safety or performance. For example, airlines. Just imagine to carry their load, it's the weight, and us and everything else, fly non-stop for thousands of miles. It has to be a complex system. You wouldn't go and say that, the wing is spreading from Kempegowda Airport to Ulster, so why don't we shorten it? No, we don't do that. Also, we don't say that, it has too many engines, why don't we half it? No, because that is safety issue, right? At the same time, it's a necessity, complexity. When you think of applications that you use on a day-to-day basis, for example, simple takeaway. I know you are using, Swiggy or Zomato, etc., etc. For you, ordering a food, just tap a few buttons, right? You get the food delivered to your, door. Just imagine how many systems behind the scenes interact and come together. Often they kind of communicate each other to provide that, simple-looking feature that you all use. So in such a situation, there has to be a complexity. And here, the complexity is a need or a necessity. So that brings us to knowing essential complexity. Remember this word. This is like the hero or the good cholesterol of complexity. I will introduce the villain later on. So this is complexity. It's not always bad, but essential for your application or serverless or the engineering stuff you do. So with that, let's look at understanding complexity. So according to Wikipedia, it pictures these sort of interactions between components. I mean, this is where most systems get complicated or people get frustrated. The reason is that when you look at some of the architectural blueprints and things, you find these sort of crisscrossing lines all over the place. Often, sort of the shapes actually, the lines that connect these applications, that's what makes us think things they are complicated. Often I see the expression of complexity. So this is so familiar in your teams, even you must have expressed the complexity. This is what it will look like mostly in your teams when you are faced with complexity. Especially if you hear the final, the wording of those things, you know that it's absolutely horrible. The reason, it's often cognitive load. Because we can only keep something stuffed into our brain. If it goes beyond, we can't handle. So you must be familiar with this picture. So those black dots are like systems or people. Just think, when you have three systems, There are simple 3 communication lines. At the same time, when you have 10 systems, just look at the number of possible communication lines. So this is one of the areas where teams struggle to contain how to minimize this number of crisscrossing communication lines to make things simple. So here is a simple serverless architecture. I know I drew more lines than required, but this is often the reality many teams adopting serverless get into, because it's so simple to get started and they get excited to keep on adding more and more communication lines and get into this kind of, the mess. And so it's important to understand the 2 sides of complexity when you work in, software engineering, serverless or cloud or anything. So basically you have on one side, you have things are all accumulated. Imagine you have one simple application, it has tightly integrated everything clumped together, so that's accumulated. Whereas when you think of the distributed nature of systems, like the takeaway aperture, there are plenty of systems spread around. So that's distributed. And the next thing, hidden and visible, also related to that. When you have a monolith that kind of tightly, integrated, things are all hidden inside. Whereas your distributed architecture, the complexity is visible all across. Though individually you may have simple services, but it's distributed all across. The same goes with when you think of disorganized or organized complexity. Even back in those 70s and 80s, with no cloud or distributed systems, people still were kind of defining these 2 sides. So those days, they thought in terms of local and global complexity. To give an example, local complexity is you have a program and imagine you have GOTO statements all over, right? So that is like local complexity. When you think of global complexity, you have like shared memory or global variables where multiple applications access and make changes. So that is a global complexity. So this kind of, thinking existed even back in those 70s or 80s. So this is roughly what I mentioned. It doesn't matter where you say microservice, but if you build a microlith or macrolith, you are actually adding complexity to the thing. Okay, so let's now focus on managing. Last year at reInvent, Werner introduced the term simplexity. So I think he took an example of an AWS service, and he explained how complex these services are, but they are built with simple principles. How many of you are familiar with DynamoDB? Quite a few of you, right? So imagine you use DynamoDB day-to-day basis. It's so simple to create a table. It doesn't matter whether you kept 10 items or 10 million items. Now think that millions of users across the globe creating billions of tables. So the backend of the DynamoDB that looks so simple for you must be a complex beast. But how do they manage such complexity? So this is where AWS brings the simplicity in terms of microservices, in terms of 2 pizza teams or smaller self-contained autonomous teams. So that is the way they kind of manage complexity across all their the entire AWS ecosystem. So this is a picture of A380 cockpit. Now, if you watch any of the videos where they refurbish airlines, you will see miles and miles of long cables, hidden behind the panels. But here, what you see, those knobs and buttons and stuff, they mostly do one thing only, most cases. So this is an abstraction of complexity, but offered as a simple mechanism to operate. Now, to do that, first, you need to decompose complexity. That's how you find simplicity. Now, how do you decompose complexity? Often people start with their, programs or applications. No, if you are in an organization, if it's completely disorganized, you must start with the organization. You must decompose the business before you get to your applications. So I won't go to the details. And this is coming from domain-driven design. I spoke about it last year when I was here. So when you have your application domains, you think of breaking that domain into subdomains, so areas that kind of, align with a particular business operation. Then once you get there, you break that down into what we call the bounded context or the boundaries of certain models or behaviors. So when you get to this sort of smaller boundaries, it becomes easier to assign team responsibility or ownership to these boundaries. So this is a way of slowly separating out the complex nature of your enterprise or organization and the applications you build. Because when you get into domain boundaries, that will lead you to define the system boundaries. This is where the distributedness coming in. And then when you have team boundaries, you think of ownership. The team owns a GitHub repository, for example. Not necessarily 100 other teams share the same repository. Then they do the blame game of who broke the build and brought the production down, etc. So here you are kind of into your own kind of cocoon area. And most importantly, responsibility boundaries bring the communication structure, whether it is synchronous API calls or asynchronous event-driven or, all the queuing and messaging, all sorts of things will become clear when you get to this stage. Okay? Right. Now, the next is prevent this stuff, communication, complication at all costs. I know I made a typo. You know what? English is let me not say that word here. It's a funny language. I can get away saying this in England, but probably here you will be like, ooh, Shane, how can you say that? There is a word simplification, but there is no word called complication, right? Why not? So anyway, what I say is, if you are building event-driven architecture, you heard about event-driven a lot already. Unless you apply your brain and thinking and do it properly, you can get into trouble building monoliths. To give an example, so here are, say, 4 or 5 systems. Imagine all these systems are running on different AWS accounts. Okay, you already heard about the event bridge, which is in the middle of each of those diagrams. And typically, you have event brokers, and then you have AWS services. You can do communication, event-driven communication between these sort of event buses. So this is ideal way of doing it. That is essential because these are essential because you need to publish, subscribe messages. Okay. Now, what can go wrong here? So this is where the other side of complexity will creep in. To give an example, I need to first talk about the trucks. And before I get there, so this is something I often say to engineers. When you use serverless, it looks everything so simple, right? Simple services. But we often get into complexities because we create complexity. Another technology, I won't name it, I let Wikipedia name it, is complex by nature, right? So we need to differentiate and identify how we work with these, simple technologies. You're all familiar with the trucks. Now we have plenty of, makes and models in India. And this one is an ideal truck-loaded picture, right? Optimum load, completely covered, tied with ropes and everything. So this is like essential complexity because they can't operate an empty truck. Now, look at this picture. This is so common. This is what is called accidental complexity. So this is the villain of the essential complexity. Remember these 2 terms because this is so important. Now, if I bring back the event bridge story, earlier this year, AWS released a new feature that allows you to invoke any resource from one account to the other account from event bridge. So you can set your target from one account to the other, invoke a Lambda function or a queue or whatever. Now, if you're not careful, what will happen is engineers so excited and they say, oh, it's so simple to do. Well, get into this. This is what I call a distributed monolith because if you get into this stage of complexity, hardly any way to get out of it without making costly changes. Now, how can you do better? So remember these things. In terms of simplification, don't bring complexity into it, unnecessary complexity, accidental complexity into your environment. Make sure your event-driven architecture doesn't become a event intrusion architecture. There is a difference. And always remember to differentiate. Question if you are introducing complexity, whether it is essential or accidental. Okay? Right. Now, how can you make it better? There are many ways. One simple way is identify a particular AWS account as your domain bus or enterprise bus account. This allows you to add governing principles and rules and policies so that there is control in terms of who subscribes, who publishes. So that is so important when we build event-driven applications. Right. So the next one is think of evolving your architecture to keep things simple. Now, if you read this book, there are a few principles or kind of guidelines mentioned in this book, and especially I like the points 3 and 4. Delaying a decision, I think that's a difference now, and if we compare to the past. In the past, we used to think of future things which we don't know and then architect the whole thing. But now we are like just-in-time architecture. So that's what gives us the simplicity, because that allows you to extend. And to extend, you need to use number 4. Think in terms of the sort of simplicity principles. Think in terms of the power of small. So to give an example, so this, right? Yeah, exactly. So hydrogen is there, oxygen is there, water we use. They say that it's 2 parts of hydrogen and 1 part of oxygen. I never seen it. I only seen water, but I believe them. Now, if you think of how all the molecules are built with this, that is a simplicity principle starting with modularity primitives. So think in terms of primitives, constructs, functions, and then microservices when you think of your serverless architecture. Because you can't go wrong. If you got one function wrong, it's so easy to replace with a proper function next time, right? Same with microservices. So this is so important to avoid complexity when you build serverless applications. So Vlad, in his book, The Balancing Coupling in Software Design, makes these 2 important points. Because when you think of modularity, it prevents accidental complexity because it's all of smaller areas. So also it allows you to kind of encapsulate or abstract the complexity so that you won't kind of spill around and make an accidental complexity situation. Now, you heard this word composition already. Serverless, when you build serverless applications or microservices, you are thinking or you're building basically composing your service, not kind of programming all the way through. You're bringing multiple managed services and kind of knitting or integrating with infrastructure as code to bring up your application or microservice. So this is so important, or the mindset shift people talk about when you do serverless. So patterns is so important when it comes to serverless implementation and keeping things simple. Absolutely, there are so many varieties of patterns, but I'm going to talk about one pattern that looks like this. So this is like when you enter a highly protected or sensitive lab, you need to wear this coat. There's a word for this, I think fumigation or something. You need to get purified. Why? Because they don't want you to bring the external elements and corrupt the things inside the lab. So there is a pattern for that. That is called anti-corruption layer. So this comes from domain-driven design. How many of you know domain-driven design? Next time when I come here, I should see more hands. So this has plenty of patterns, and the anti-corruption layer is basically from here to protect your data and everything. So what it is basically a translation layer that allows accept data from one end and translates to fit into the other one. And think of two applications or two systems, right? And upstream, downstream. And the data flows from upstream to the downstream. And because the upstream system and downstream, they have their own data models, data structures, schema, everything. So when upstream pushes down, it's not going to comply with your downstream because there are hundreds of consumers. So the data comes from upstream's model. So you need a layer to bring that into, translate, before you take into your author. It's like, rivers trying to merge with the seawater. There is always this challenge, right? So that is the thinking that you should have. Now, this is from Lord's book again. So if you don't do that, this is the mess you will get into, because you are basically accepting rubbish. Your model will become rubbish. So finally, refactor, okay? Don't stack up complexity. So Werner said, sneaks in all the time. So you need to think of refactoring all the time. Refactor the olden days is, like people thought of, object-oriented programming, but now serverless, you need to kind of rewiring the, refactoring as well. So there are plenty of ways you can refactor. There are, not just the program code infrastructure and everything. So refactor complexity, okay? To close today, think of all these things that I spoke about, okay? All the good things that you need to remember. And, the Tangle system you can avoid if you build event-driven applications properly. I leave you with this final thought. So these days, you cannot get away without distributed systems because that is part of our, living. So always remember, when you build something, is it essential or is it accidental? So thank you ever so much and enjoy the great conference. I'm here all day. Let's talk serverless and complexity. Thank you.